Jai Hind. Today we are going to start a very important topic, memory hierarchy. So, myself Dr. Akhilesh Verma in the Department of Computer Science and Engineering, and let's start this topic, memory hierarchy. Students, we are having a very big challenge to design a computer system that provides a sufficiently large memory, first requirement, and we also need that the memory, apart from large, it has a reasonable speed, that is, it should not be a slow, and obviously that both of things I require at the affordable cost. So, considering these three aspects, the need for sufficiently large memory and some reasonable speed, and we have to pay very less. So, if we see that availability of memory in the hardware form or the market, there are three categories of memories that we can see. One is the static memory, another is the dynamic memory, and there is another memory that is called as magnetic disk. There is various trade-off that we can see from the comparison of these three types, and they are not individually sufficient to provide the sufficiently large space or having a reasonable good speed, and the cost wise they are affordable too. So, if we study these three types and identify their complexity, or you can say features, we can go for the concept of memory hierarchy. What is the memory hierarchy? So, if we see the first RAM, that storage, that is static RAM, it has a characteristic that is very fast, but the one cell is very complex. So, it is impossible to pack large number of cells onto a single chip. So, we can not have a large memory size using static memory, even though it is fast. On the other hand, if you see the dynamic RAM, it is simpler in the circuit. So, the complexity of circuit is very simple. So, it is less expensive, but what is the drawback here, that SRAM, that is static, the dynamic RAM is slower than the static RAM. Okay. So, this is slow and this is fast. It has packaging capacity low, so large number cell cannot be packed. So, the storage capacity is small, and it has higher capacity, but it has slow, so there is a drawback. So, which we can choose. Now, if we see for the large storage, we can have a possibility to choose the magnetic disk also. So, if we have a storage devices to be compared with the magnetic disk, so we can say the storage provided by DRAM is higher than the SRAM, but it is still less than what is necessary needed for any program. Okay. So, nowadays the program size are not in KBs, they are in MBs, or in fact the program size or the storage of data for the particular execution of program is in GBs also. So, we cannot fulfill the requirement with the static RAM and DRAM. So, we can go for this secondary storage such as magnetic disk that provide large amount of space. But what is the drawback here? That is, it is very slow than the DRAM itself. So, students, all these type of memory units can be employed effectively. Yes, it can be employed effectively. So, we can club the feature of all these, okay, and use them, and that we call that type of particular memory is the use of computer with the help of memory hierarchy. Okay, computer with the memory with the help of memory hierarchy. So, computer memory can be viewed as a hierarchies of these memories, and that will be effectively used as a single memory unit. Fine. Okay. So, how it's look like in a block diagram? So, we can see here that processor has its own memory that we already know as the fastest space, that is register on board. Okay. Fine. So, fastest access memory that is available as a register in the CPU or the processor chip itself. Apart from that, we can have a relatively small amount of memory named as cache on the processor chip itself, and it is named as L1 cache, level 1 cache. Okay. So, it is very small. Additionally, the architecture of the computer designer can also, they also suggest that we can have level 2 hierarchy of cache, that is outside the memory chip. So, we can have two levels of cache, L1 that is within the processor, and L2 that is outside the processor. Further, if we see, we can have more levels of main memory, okay, apart from the cache, and they can be implemented in a single inline memory module. Okay, basically they are called as SIMs. Okay, so the memory chips or main memory chips are implemented in hardware as SIMs. Okay, so basically it is a large space of the SRAMs and DRAMs. In particularly, we can say they are dynamic RAMs, okay, which are arranged in a organizational manner, that is called a single inline memory modules. So, many memory modules are connected in a line. So, there is a single line of modules of particular memory chips. It can be dynamic RAM. Fine. Now, further, to have a more storage, we can have a magnetic disk that will have a relatively high or huge space, and it is also inexpensive storage. So, if we see the relationship here from top to bottom or bottom to up, we can see here the speed of memory access is critical, and idea is to bring the instruction and data that will be used in near future close to the processor as much as possible. So, if we see this diagram, this is a space where the increasing the cost per bit is low, but here cost per bit is very high. So, what will happen? We can put the data to the particular memory which is very critical to access. So, we will bring those instruction and data that will be used in near future, means that is predicted that it is going to be used later, and we will bring it as much as near to the processor, that is the primary cache, and we can also have some registers to include the pipeline of instructions or data within the registers also. Fine. So, processor is the one of the fastest unit in the computer, and it is faster than the main memory. So, how you can provide a data to the processor if the memory is slow? So, we can see that as a result, processor spends much of its time waiting, means it is doing nothing, it just wait for the data to be fetched from the main memory, and this is the major obstacle for the designer, apart from a very large effective memory. Okay. So, how you can deal it? So, to deal with this such problem, the speed of the main memory cannot be increased beyond certain point, because there are some limitation, like microprocessor is not on the same chip or you can say same bus. It is separated by a bus and it is put on another board where these SIMs are arranged. Okay, as SIMs are arranged, single inline memory modules are arranged. So, there is a distance by which it is beyond a certain limit that it cannot improve. So, the cache memory is an architectural arrangement which makes the main memory appear faster to the processor than it really is. That we can see here that we have put a cache memory. So, bringing data from again from main memory to the processor is costly. So, we will bring some data in the cache. Okay. So, cache memory is based on the property of computer programs known as locality of reference. So, new term that we are getting here is locality of reference. What is locality of reference? We can say it in very short form LR. So basically we are having a location of our reference. Okay, we know the location. Okay, we know the location of what for our reference. What we are going to refer? We are going to refer either instruction or we are going to refer a data. So the term that is used for location of a particular reference is known as locality of reference. So cache memory is using the principle of locality of reference, which says that computer programs have certain behavior. Okay, and that behavior is known as the property of computer program. So if we know the property of the program, we can easily identify the location of any reference in future that we require. So analyzing the program, it indicates many instructions are localized in area of a program that are executed repeatedly. Okay, that we have seen with the program behavior. Okay, and during some period of time. Okay, so particular area. Okay, or you can say code of particular code is repeatedly used, and it might be possible that at particular time of juncture a particular code is used, and other are accessed relatively less frequently. That can be easily understood by the program behavior. So these instructions may be like we have seen in the program behavior, there are loops, nested loops, or some procedural call which are called again and again, like recursive. Okay, so the code is recursively called again and again. So repeated particular area is called. So this is called as locality of reference. So we can see that the locality of reference can be dependent on the two things. One is the temporal nature, that is temporal locality. Other is the spatial nature, that is spatial locality. So what does temporal locality reference means? So if we have executed some data, so recently executed instruction is most likely to be used again. So that is temporal. So on the time scale line, it is having a chance that a particular data that we have recently executed may be executed again and again. That is called as temporal locality. While in the spatial locality, reference instruction with address close to recent instruction are likely to be executed. So I am executing a particular instruction, so there might be some close instruction here and there. There is a possibility that we can be using that particular instruction. So based on that probabilistic decision, either temporal or the spatial, we can identify the program behavior. So cache memory is based on the concept of locality reference that actively finds some program segments and bring into the main memory, from main memory to cache, and then the time to bring that is reduced. So temporal locality of reference, okay, whenever instruction or data is needed for the first time it is brought, while in a spatial locality, instead of fetching just one item, we can bring more items into the cache that is adjacent to the item being fetched. So the group of that particular set of item brought into the cache is called logically a block that is brought from the main memory to the cache. Okay, so how it looks like that there is a main memory, there is a cache, and the processor issues a read request. A block of word is transferred from main memory to cache one word at a time. So there is a block. Okay, there are multiple words. Okay, so this whole block will be transferred here. Okay, but one word at a time, word 1, then another word 2, and so on. So in period of time, this particular data will be copied here. Okay, so block of word is transferred from main memory to the cache one word at a time. Now subsequent reference to data in this block of the word are found in the cache. Obviously, if the next word is fetched within this block, it is available here. At any given time, only some blocks in the main memory are held in the cache. So it is limited in size, and then only few blocks can come into the cache. So it is quite obvious that it will carry only few blocks, okay, or limited blocks. So there is a one simple issue where to place these blocks in the cache. So there is a mapping function that is called as placement of main memory block to the cache memory block, and when it is full and the block of words need to be transferred from the main memory to the main memory, some blocks words in the cache must be replaced. Okay, so certainly first we have to map. So when we bring here, it is called as map. Okay, and when we remove, so certainly when we remove, so the replacement algorithm should be designed. So two things are required in the cache memory, the efficient mapping approach and the efficient replacement algorithm to optimally utilize the cache. Now students, we must understand another requirement, that the cache is transparent to processor. What does it mean? The processor issues read and write request in the same manner, okay, as cache is not there. Okay, so basically processor is not aware about the cache. So if data is in the cache, it is called read hit, and if data is not obtained, then it is brought to the not apparent, it is brought from the main memory. The cache is replica that contains the main memory, and contents of the cache and the main memory may be updated simultaneously. In that case, we need to have a policy, that is if you are writing throughout, that is called as write through WT. Immediately we are writing and update the contents of the cache and mark the updated setting bit known as dirty bit or modified bit. Okay, because the content of the main memory are updated when this block is replaced, and this is called as write back or copy back protocol. Okay, so if you do it, we are writing immediately, there is no need to have a inclusion of dirty bit, but if we are doing later, okay, so what is required, that the bit of block status should be updated with the dirty bit, that it has been modified, so nobody can be able to read it. Similarly, there is a possibility of read miss and the write miss, because when we are trying to read and it is not available in the cache, it will be having read miss. Okay, so a block of word containing this requested word is transferred from the main memory. Certainly, if it is read miss, after the block is transferred, desired word is forwarded to the processor. Desired word may also be forwarded to processor as soon as it is transferred without waiting for the entire block transferred. This is called as load through or early restart. Now we have already discussed that the word will be brought from block to cache word by word. Now if you are requesting certain word that will be 10th or 8th within the block, so it will be fetched after 10th interval. But there are certain times that we require that the particular word is read immediately or required to be read immediately. In that case, we can start a load through a particular word, or we can particular word is brought from the main memory block to a cache memory block. Instead of bringing, first wait for the block. Similarly, write through protocol is used, then that contains the main memory are updated directly to the main memory as well as the cache memory. And if there is a write back protocol is used, the block is containing address word is first brought to the cache, and then desired word is overwritten with new information. Fine. So there is a need of significance of one important bit, that is called a valid bit. Valid bit are set to 0 when power is just turned on when we are installing the computer, and if the block contains valid data, then the bit is set to 1, else it is 0. So when we transfer data between main memory and a disk, okay, directly bypassing the cache, certainly when data on the disk change, the main memory is also updated. However, if data is also resident on the cache, then it is valid? No, it is said to be 0, because there is an exchange between the main memory and the hard disk. Fine. Likewise, what happens if data and the disk main memory changes and the write back protocol is being used? In that case, data in the cache may also have been changed and is indicated by the dirty bit. So students, you must understand what is the role of dirty bit. It indicates the status of the block available in the cache, that is usable or not usable. So processor will look first dirty bit, okay, then it will decide whether it has to read it or not. The copies of data in the cache and the main memory are different. Okay, this is called as cache coherence protocol. The moment or time period in which the block of main memory and the cache are different, so they are not same, so they are not coherent to each other. So the moment or period during which these two blocks are different is called as cache coherence problem, and the option for the one option is to force write back before the main memory is updated from the disk. Okay, before some data come from the hard disk to the main memory, we must ensure that the whatever the changes that you have done in the cache, it should be reflected back into the main memory. So, this is very important thing that we have seen today for the purpose of understanding the a very large memory, high speed, and also understanding the validity of data in the cache in case there is update in the main memory from the secondary storage, and likewise from the cache to the main memory, then it is updated back to the secondary storage. Okay, thank you and Jai Hind.